Hello guys, welcome back. Now let's have a look over a new ADC, that is analog to digital converter, and it is MCP3428. And to search this sensor, let's roll upon the website, that is controleverything.com, and here we have to type in for the sensor for the ADC exactly, and it is MCP3428. And by searching it, let's see what we got here. As you notice, it's a 16-bit 4-channel analog to digital converter, and these are some more prominent features of this very ADC. And you can also purchase the sensor from this site right from here. Furthermore, I will be interfacing the ADC MCP3428 with a particle photon, and the software platform I will be using is a particle code. And let's go to resource tab, and here comes the particle code sample. You can download the particle code sample there as a zip file right from here, and also you can get the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware connection that we need to set up together, and let's see how we got there. Well, coming to the hardware connection setup part, the first thing we require, which you are able to see on my screen, is a particle photon. Now this here is an I2C Shield. It's available and can be purchased from the website controleverything.com, and the reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this particle photon over the I2C shield and make a connection just like that. Now to power up this particle photon, what do we require is a micro USB cable, which you can see on my screen, and gently insert it over this power jack. Next, this here is our analog to digital converter, that is MCP3428, and this here is a connecting cable. Now make sure that while making a connection with the cable and the ADC, the brown wire of the cable should be connected to the ground terminal of the ADC, and similarly to the ground terminal of the I2C shield. So these are the connections we required for this hardware. Now let's proceed with the code. Now coming to the interfacing part, we have to first of all log in to github.com, and after that we have to search on for the repository, that is Control Everything Community, and here it is. And let's proceed, and here is our ADC, that is MCP3428, and let's proceeding further, and as you can notice we have the particle code here. But let's have a look over the instructions we need to fulfill first. It says that we have to log into our particle photon and set up the device, and the steps are provided on this link. As you notice, when I will open this link, you see a lot of instructions, procedures, commands which you need to fulfill carefully. After getting that, we have to download the kit or get full the code, and we have the online ID, and we have to copy the code there. And build.particle is the online ID where we have to first of all create a new file. We have to save it, and after that, as you notice, we have to verify and flash the code on the particle photon, and the code output will be shown in the form of logs at dashboard. And this is the dashboard.particle link for the user logs, where we will have our respective output data. After getting that, we get back to the particle code, which, as you notice, it's a .in extension file. And in the code, first thing you notice that we have included application.h and spark wiring I2C.h header files. And we have defined the address of the sensor, that is 0x68, and we have initialized an integer that is for the 0. And we have in the void setup function, we have some variables, as you notice, and we have initialized I2C communication as master with start serial communication with the baud rate equal to 9600. Then we, in the writing part, we are going to select the configuration command, and we are going to send a command for continuous conversion mode channel 1 12-bit resolution, that is 0x90. And then we have in the void loop function, as you notice, we have to select the data register, that is 0x00, and we are requesting and reading 2 bytes of the data from this very register. Then we have the conversion of the data takes place and into 12 bits, which we have followed from the instructions provided in the data sheet of ADC, that is MCP3428. And at the very end of our code, we have the output data onto the dashboard, which you see as the digital value of analog input. So this is how our codes look like for the particle for the ADC MCP3428, and let's see how it works. Regarding the interfacing and now the working, first step, we need to copy it, as you are able to see, and after that we need to open up the build terminal, and here we need to create a new file and paste the entire code there, as you notice. and just like here, and let it name it MCP3428, which is the name, and let's save it. And after that we need to verify and compile the code, and it's a great work. Now we need to flash the code, and while flashing we need for a magenta flash which confirms that code is good to go and we can have our output data onto the screen. So just now we have the magenta flash and the successful notification is right now. After that we have to see the output data onto the dashboard and in the form of logs, and here it is. We have the digital value of analog input and it's 0 because both the ends are grounded, there is nothing connected among them. But instead, when I try to connect a AA battery of 1.5 volt, it's a AA battery of standard 1.5 volt, I connect it and we have the raw value which is 1107. It's a constant coming because some potential is going on among the two ends. Now this is how the sensor responds. Now let's have a look over the benefits, features and applications regarding the sensor. The MCP3428 is a low noise and high accuracy 16-bit delta sigma analog to digital converter, family member of MCP3428 series. This device can convert analog inputs to digital code with up to 16 bits of resolution. Due to high accuracy in analog conversions, the applications of this ADC are portable instrumentation and consumer goods, temperature sensing with RTD thermistor and thermocouple, bridge sensing for pressure, strain and force, weigh scales and battery fuel gauges, factory automation equipment. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.